9.3 is all about cross sections of three-dimensional objects. And if I were to remove like a wafer thin two-dimensional object from a three-dimensional object, what would that two-dimensional object look like? What would it be? Okay, so here's an example. I have a two or a three-dimensional cylinder, right? Kind of shown like right here. This is a two-dimensional cylinder, or, a three-dimensional cylinder. And if I look at it like this, right? And I were to remove, say for instance, it kind of looks like a what? It kind of looks like it's a rectangular shape, right? So if I were to remove a wafer thin shape from that, it would be a rectangle, okay? But if we look at from this perspective, from this point of view, right, it looks like it is a circle, right? So if I were to remove a wafer thin piece from that section, right, that piece that I have is a circle, okay? So that is what the idea of a cross section is, right? So if I I have a triangle, right? Right, but if I flip it this way, I have a circle. But in actuality, I have a cone, right? So at any given point of this, I have a different sized circle, right? Based upon where I remove the cross section from, right? Because as the cone gets bigger, as I go down, the cross section becomes larger. Therefore, the circle of that cross section becomes bigger. But if I go over here, if I move closer or further away from the center of this, the bigger or smaller the triangle I would remove from the cross section of this cone would be. Okay, here I have a rectangular prism, right? From this side, I have a rectangle. From this side, I have a rectangle. From here, this just happens to be a square. Okay, so the cross section of an object. Well, here I have here's a pyramid, right? From this side, I have a triangle, right? From this side, I have a square, right? So depending on which side you come from, right, you have a different shape, okay? So that's the whole idea of a cross section. All right, so here is an example. Maybe I can zoom in a little bit of some of the questions you might see. What shape is created? Here is given a pyramid whose base is a square, right? What shape is given by a horizontal? So this is vertical, this is horizontal, okay? So what shape is created by a horizontal cross section? Right, so here's my pyramid, right? Vertical would be this way, horizontal is this way. So if I'm looking at it horizontally, right, if I were to remove this, a horizontal cross section would be a square. Q-U-A-R-E, it would be a square, okay? If a pyramid is square, base is 81 square inches, okay? So the base is 81 inches squared, and the height is 15 inches squared. What is the area of the horizontal cross section? 16 inches from the base. All right, so this is a similar triangle question. Okay, so it means that this is area. So what is the length? It's a square. So 81. That means that the square root of 81 is 9 inches. So this is a 9 by 9 inch square. Okay, so I have, if it's 9 by 9 inches, I have a pyramid whose 4.5 like this and this. So I have a pyramid whose height is, whose height is 15. Whose height is 15 inches. Okay? So, and then it says that the cross section is located 16 inches or 6 inches from the base, right? So that means that this height here is 15 minus 6, which is 9 inches. Okay? This angle is common between both of these triangles. This angle and this angle are the same, and this angle and this angle are the same. So either way, I have two angles, and because of angle, I have two similar triangles of angle similarity. Okay? So now I can say that I can set up my similar triangles. We'll say that this is one triangle, and my purple one is my big triangle. Okay? And I'll say my triangle, and I need to figure out this is 1/2 my base. This is my base. This length here is the base I'm trying to figure out. And it's so I have my purple triangle, that looks like this. And I have my big burgundy triangle, that looks like this. And I know that this is 15. I know that this is 4.5. And then over here, I know that this is 9. And I'm trying to figure out that. Okay? So that's what I'm trying to figure out. So I go 9 divided by, I'm gonna put my unknown on the top, makes the math easier. So I'm gonna call this B, sure. Right, B2, sure, whatever. Okay, I'm gonna call that, and I'm gonna put equal divided by 9 equals. So what is my similar part of this? It's gonna be 4.5. Right, because that's half of 9. That was half of the base. Right, because it's half of this triangle. This triangle is half of my square, right? And that's going to be divided by 15, right? So I'm just going to multiply both sides of this by 9, right? So 9 times 4.5 divided by 15 is going to be equal to half of this, okay? Half of this length right here, all right? So 4.5 times 9 equals, divided by 15, equals 2.7. So 2.7 equals 2.7. All right, so if it's 2.7, what is the area of the horizontal cross-section? 6 inches from the base. Okay, so 2.7, now I've got to double that, times 2. Equals 5.4, so 5.4, so 5.4 squared is 29, equals 29.16 squared inches at this point right here, okay? So, and then if this was remeasured and find a height of 12 inches, and you would just adjust this height to be 9 or 12 minus 6, it changes this to 6. So it changes this to 6, so it would be 4.5 times 6 equals, divided by 15 equals, it would be 1.8 times 2 squared, and that would be 12.96. 12.96, and of course, as the height goes up, the area of the cross section, as height goes up, area goes down, therefore they are inversely related. Okay, so that's some of the stuff you're going to see here. Okay, and in a cylinder, you can see that there is no inverse relationship, right? The area is going to stay the same because it doesn't get narrower at the top, right? The area, because the area of a cylinder is base times height, and the base of a cylinder is the area of a circle, which is pi r squared. So area of a cylinder is pi r squared times the height. Okay? So as height changes, nothing else changes. So the diameter across this is going to be the same. All right, so hopefully that helps out. And If you had any further questions, please let me know.